In this lesson, we're going to see how to raise our own exceptions rather than rely on exceptions being raised by the Python system. A place where you might want to do this is in a class definition for when the user enters some data wrong or some other event occurs. We'll use that as a basis for demonstrating how to raise our own exceptions. So let's start a new program. We're going to call it raise.py. What we're going to create is a class to store rational numbers. I'm not going to go very deep into the implementation of the class. I just want to show you what happens when you try to instantiate a rational object with 0 as the denominator, which will lead to a zero division error. So we'll go directly to the definition of the constructor. The constructor will consist of 3 parameters: self, x, and y, representing the numerator and the denominator. So in the body, we'll write numerator equals x. Then we're going to say if y is equal to 0. In other words, if the denominator is going to be a 0, then we want to raise a zero division error. So what happens is, if this raise statement is executed within a try, then it will throw that exception to the except clause in the try statement, if there is one. Let's finish off the definition, else denominator equals y. That's all we're going to do. That's enough to demonstrate how the raise statement works. So let's try to create a rational number. Let's create rational 4, 1. And then let's create another one, rat2 equals rational 3, 0. Let's save the program and run it. And there we can see that a zero division error was raised when we tried to create a denominator of 0. Let's go back to the program and let's put a try statement into the program. And what we want to do is we want to add an except clause so that we can print a statement other than just the raw error message. So we're going to say, cannot have a rational number with 0 for denominator. Will be our little statement we're going to print when the exception is raised. So let's go back, save the program again, and then let's rerun it. And there we see that this time, just like before, trying to create a rational number with 0 as a denominator causes the exception, but this time our little statement is printed rather than the raw error. And again, that happened because we tried to create a rational number with 0 as the denominator. And when it didn't work, then our print statement was executed. So with that, we're finished with this lesson on the raise exception. And now we're ready to move on to the exercises for this chapter.